Hello, Hyvää päivää, and thank you very much for the kind invitation to join you today and to present my project at this conference. I don't have any slides, so I'll just be talking, and hopefully we can have a discussion. I'm just gonna share my screen here. There we go. Great. Let me know if everything's working okay. So I started Cousteau Divers, a nonprofit organization for citizen science and conservation in 2009. Originally what we were doing was collecting images from scuba divers, photography from all over the world, and having all of these images geolocated and time-stamped, and asking people to add some tags to the images, which would help to get the presence-absence of species during dives, and to help make the observations of recreational divers helpful in the future for science. Originally, we also tried to collect some data using underwater slates, so counting fish, recording observations of presence and absence of species and of human impacts and things like this. And since 2009, it's been a journey of simplification, going from these underwater slates to post-dive logs, again, noting observations, to today, the Remora device, and trying to record the most basic parameter, which is temperature, with some measure of accuracy that makes it helpful enough, or at least useful for scientific uses. So what we've done is develop this machine, the Remora device. And the reason we had to develop a new machine is because we tried, originally I wanted to use dive computers who record temperature, but after many tests of many different computers with many different manufacturers in different conditions, we found that there's too much inaccuracy and too much thermal inertia with the devices to be useful scientifically. Most dive computers are off by 2 degrees Celsius. So if you dive, and I'm sure all of you are aware of this, if you dive with 2 different computers to the same depth and you compare the temperature profiles, they could be off by 2 degrees from one another, even though it was more or less the same dive. So realizing that it would be difficult to use this information in a meaningful way, we had to develop our own not dive computer, but temperature, let's say data logger. And that's what this device is. It's a data logger. And at the moment, it measures the depth. It has a GPS chip and the temperature. And this allows us to get the entrance and the exit of the dive, the GPS coordinates, and the temperature with a 0.2 degree accuracy Celsius. So something that's actually usable by scientists. And so it took a long time to develop this machine, thanks to the help of volunteer engineers. And today we have the device, which is in its first stage in the pilot phase. And the device is the Remora. Wait, let me see if I can. Yeah, there we go. So this is the device. It's what it is, and we've been using it for a year now. We have 50 of these units distributed worldwide to dive centers and very active divers. Try to get as much data as possible in this pilot phase, and we've learned a lot about the device and its shortcomings also. And this has allowed us to improve it. And at the moment, currently, we're we're testing prototypes to overcome those shortcomings and to Most importantly, increase the lifespan of these devices, because the first ones that we've distributed a year ago, or almost all of them, have either flooded or corroded in some way, and so most of them are out of service. But the improvements that we're bringing should hopefully expand the lifespan of these devices by several years. So here you have the device. These are the sensors here. So you have a temperature sensor, a depth sensor, and a water sensor. This is an empty port. But as a data logger, you can see there are many empty ports. And so in the future, we're hoping to add conductivity measurements, salinity, pH, dissolved oxygen, luminosity, sound, even measuring passive acoustics. So there's a lot of things we can do with this device that's very modular for the future. And as you can see, we have, we have recorded in the past year 1,640 dives to date. At the moment, a lot of these devices have, like I said, unfortunately, gone out of service because of flooding or corrosion. So there's only a few contributors who still have working devices at the moment. And you can see here there are data summaries that we display on the website in real time that show the temperature at 1 meter and the temperature at the maximum depth of the dive. And for each of these, what we receive is this more detailed, because the device is measuring every second. We have the detailed dive profile, which we don't publish in real time online for several reasons, including privacy, because we don't want insurance companies or other divers criticizing how one dive operation dives. As you know, ascent rates and things like that can be a risk factor in diving. Yeah, and so this device is all made available on request to scientists and educational organizations. And so that's it in a nutshell, really. That's all I had to show. But I'm very happy to entertain any questions you have, and maybe things I forgot to mention. So any discussion we can have about this project, I'm very happy to be here with you guys today.
Okay. Thank you for that, Pierre Yves. We have one question, one raised hand.
That's David.
From David, please ask. Go ahead.
Yeah, so hi, that was very interesting. It looks like a great object to be using for the future, a methodology. Outside of your project, how do you project in the future the idea of licensing to other groups to use? You know, sort of like scales of money and licensing agreements and things like that. So if I was to use it in Finnish lakes.
Okay, you mean licensing of the, so you mean acquiring one of these devices?
Yeah, sure.
So, okay, so at the moment, the way this is funded is through philanthropy. So there's, you know, IWC, which is a Swiss watchmaker, funded our first 50 units. The second 50 units that are coming out this year are funded by our partner, Blue Robotics, in the United States. So they're the ones who assemble these machines. And so I'm giving them out basically on a case-per-case basis to people I know are going to be in the water 2 or 3 times a day, every day. Because in this phase, we really want to get just more data and learn from the machine and improve it. But in the future, this device will be for sale on the Blue Robotics site, with, you know, a commission going to the nonprofit to help fund the database and maintaining the project. And so, yeah, in the future, anyone can just go online and buy one of these. We expect that the price should be around $400 to $500 a piece at the moment. But because we're still changing the machine, we're not 100% sure what the final price is going to be on these. So Yeah, at the moment you can't get one. You can request one on the website if you just send a message on the the contact sheet, and that I will automatically put you on the waiting list, and then contact you once devices are available and try to ascertain how often you dive, and therefore if you're going to get one of these next 50. But in the future, they'll be, you can just buy them online on the Blue Robotics website.
Yeah, I have here a question from Mina Mäki. It's actually the same one I posted to you. Do you think it would be interesting, you would be interested to test the device also in the Baltic Sea?
Absolutely. Yeah. Wait, I think I'm still sharing, so we can see here the data. So we don't really have a lot of data in the Baltic. There's none actually in the Baltic Sea at the moment. So yeah, absolutely. The better coverage, the more coverage we have, the better. I'd be really happy to have a station up there. Either a dive center who dives the same dive sites every day, 3 times a day would be fantastic, or divers who go around diving in the Baltic Sea would be great too. So absolutely. And there are, people have also asked quite often freshwater versus saltwater. This was designed for sea, but it is being used in freshwater as well. For example, in Scotland, where it's extensively used at the moment in these brackish and fresh waters, and in the Netherlands also, where they use it in quarry diving. And for currently, in terms of the end use of the data, the main user of this data is Copernicus. So they're comparing Sentinel sea surface temperatures to our data, and trying to extrapolate sea surface temperatures and the depth, the temperature at depth. So this only really works for them because of the size of the satellite pixel. This only really works for them if the dives are made pretty far off the coast. So being in a quarry really doesn't help because the satellite can't make the difference between the quarry and the land. But the further away from the coast, the more helpful this data becomes for satellite observations. But anyway, sorry, I'm going on a tangent here. So yeah, just to answer your question, it would be great. That's right.
Yeah, thanks for that. I think it was a good, helpful to understand what the data are actually used at the end. I can say that here in Finland, we are working on a project where we also take temperature from lakes, perhaps, and trying to find the use in climate modeling, so microclimate modeling in that case. So it would be very useful, of course, to have this device here also to calibrate then or compare dive computers to the accuracy that Remora has, so we can maybe discount or subtract in our calculation the bias that the devices bring, the commercial devices bring from the market. That's one thing. And the other thing is coming back to Mina, who was asking the question. What I would try to do is, and we have what we do here now actually in this event, is building a network between divers. And what we would give an effort that I can commit myself to is to make sure that the device is as often in the water as possible. So using that network to distribute it, to share it with divers, that we get the biggest coverage possible for the same device. Knowing that getting equipment, specialized equipment, is very difficult. I think we all appreciate that kind of access to things and sharing stuff.
Great.
Especially, yeah, that would be really something to look forward. And then for the funding, of course, once the things work and we have something to show, I think it will be also easier then to convince funding bodies to maybe give more money for extra devices.
Fantastic.
And to continue with research. So that is at least at the moment where we are standing and thinking from our end. There's still one question, or there's one.
Can I
David has the hand open still, yes?
Sorry, can I just chime in before the question? Please hold your question and don't forget it. But speaking of using recreational dive computers. Let me just share with you the experience I've had testing them and finding their limitations. I think one of the biggest limitations was the thermal inertia. So the temperature sensor is inside the body of the computer, and so usually it perceives the change in temperature with a delay in time during which you've changed depth. So that's why you have drift a little bit. So that was one of the things, and the second one is that within the same brand and the same model of computer, you're still going to find some variability. So you can't assume that your tests for one dive computer are going to be valid across other dive computers of the same model. So that was what we found in our early research. So just sharing that with you, but yeah.
Yeah, important. Thanks. That's definitely something we need to consider for whatever we use those things for. The other thing was what you mentioned is the lack of GPS data. On the other hand, they are coming more and more computers with GPS actually on the market, so that limitation might be overcome very soon in the future devices. But what you say with the temperature, that is absolutely correct. Some are very inert, some are less inert, and it's very difficult to calibrate that.
Yeah.
Okay. So there's certainly more questions. Please ask them. I would reach out to the 30 participants we have now. Please ask your questions. David has one. Again. David?
David, you are muted.
I got it again. Have they been used in Arctic conditions at all, or semi? Because we have obviously quite cold winters in Finland, and the conditions underwater can be, 2 degrees.
Yes, absolutely. So we have had a user take it to Antarctica. So we have a couple of data points in Antarctica. Our user was very frustrated because obviously this is the kind of once in a lifetime trip, and he only recorded 4 dives out of the 10 or 15 that he did because and I'm not sure if this is due to the temperature or the corrosion. I think it's mostly due to the corrosion and the fact that, this was part of the limitations of the first device, is that it was because we were detecting water by testing the conductivity between 2 pins there was an electric current, so it was corroding, and the corrosion was also making it harder for the device to charge. So sometimes you would go diving and it wasn't fully charged, even though you'd left it charged overnight and things like that. So I think that caused a lot of frustration, but I don't think the cold itself played a big factor in the device's performance. But I could be wrong, especially in these extreme conditions. But yeah, no, Arctic would be really, really cool to get some Arctic data.
Yeah, and how do they stand up if they're actually just left on the ice for 5 minutes?
So
Underwater.
Yeah, and that's actually we had 2 modes that we want this device to perform in. There's a static and a dynamic mode. The dynamic mode is when you're diving, and the static mode is so you press a button and you open it, you press a button, and then it basically, instead of recording every second, it records every minute or every 30 seconds, and you leave it for months underwater, and then you go and pick it up. So that's a second kind of mode. We haven't, because of the corrosion issue, we haven't developed that yet, but hopefully with this next version, this is something we're going to be able to implement in terms of software.
Yeah, that's quite interesting, because one of the things that has been talked about a lot is not just recording bio data, but also putting one of these devices on a wreck, so we can do the bio data, and at the same time we can look at things like how the conditions on a wreck change through time.
Yeah.
Which are not always the same seasonally, especially if they're relatively shallow.
Yeah.
So we need how wrecks get damaged as well as understanding biodata. Two birds with one stone.
Absolutely. But I think, to be honest, to be fair, I think there are commercially available equipments that for static use will probably outperform us. I mean, I'm thinking like, the hobo sensors they're what everybody uses at the moment for static measurements, even though they have quite a bit of thermal inertia and quite low accuracy. And I think they're actually probably cheaper than our devices, and they've just been extensively used throughout the world for a decade. So probably for static use, there are better options out there, but yeah, for dynamic use, this was designed for dynamic use because the sensors are outside the housing, picking up the changes in environment as soon as they happen, which is not something you necessarily require so much on a static if you leave it on a wreck, for example, where the temperature is not going to fluctuate that much or that quickly.
I think this is a very important aspect, yes, dynamic versus static, because in the water the temperature change is much slower. It's unlikely that it jumps for a degree in 1 minute, so that's not going to happen. That's absolutely true. And corrosion, yes, corrosion of contacts, that is a problem that we have seen with other devices also, that this happens. And yeah, you need to avoid any sort of current underwater.
Yeah.
That's no good. The problem is, of course, if you need for the conductivity measurement, you need it. For other things, I mean, for charging, you could have a how is it called, wireless charger. For the data, you could have wireless connections, also Bluetooth or whatever when you retrieve it. So you can work around. You can work without contacts. It's just for the conductivity, I think. And if you want to connect maybe something underwater, because the Bluetooth is not reaching very far. It costs a lot of energy.
Yeah, we explored the wireless charging with this new prototype. We dropped it, unfortunately, because the thickness of the housing that you need in order to resist, a 60 we're rating it to 100 meters. Right now it's rated to 300 meters, which is a little overkill. But the thickness of the housing makes it hard for the wireless charging. And what we were seeing when we tested it is that we got heating from the charging because of the distance between the charger and the coil. And we don't want heating while you're charging, because if it starts to heat a little bit, that's fine. But if there's like a grain of sand or something and the distance increases and it's going to heat more, we don't want to create fires in dive centers and things like that. So we dropped the wireless charging altogether because of that issue. But now we're going to be using like a little magnetic pin, but we're decoupling the water detection from the charging. And that's going to help us avoid any kind of current while the device is underwater.
Yeah, that sounds like a good step. Yeah, and 300 meter we don't dive, no. I think the Baltic doesn't give that depth actually. No questions. There's another question in writing I see from Emma. Merci, very interesting. You mentioned cooperation with voluntary engineers. Could you tell more about the different cooperation you have had while making these devices? For example, we all found through our financing partners or university.
Yeah, sure. So originally, we the project I started it off with a Kickstarter and crowdfunding, and at that time I was still in the mindset of using recreational dive computers and just centralizing the information. And it's during the crowdfunding that we discovered that this was not really a viable option for what we wanted to do, and that we had to develop a whole new device. And that's when I met two US-based volunteer engineers who had already worked on something similar for agriculture, for soil moisture detection. And so they had already kind of something in the works. And as a side project, this was not their day job, as a side project, they both really contributed to develop the first version of the Remora. And so they got it to like 80% done, and then COVID hit, and then they went to do their own thing, and they stopped working on it. And it took several years for me to put together the right team to complete their work, and now to improve on it as well, and to overcome the shortcomings of this first version. Then sponsors IWC, a great sponsor that's been supportive of the Cousteau Society and the other activities of the Cousteau Society for many years. And so they also funded the launch of Cousteau Divers in 2009, so the website development and the whole beginning of the project. And these are kind of end users, so they're not really, I don't think that really addresses your question, but let me see. Financing or universities. There hasn't been any really organic partnership with universities at the moment, although we've received help and interest from many different universities. Right now, we're working with a university in Spain to do kind of a statistical analysis of our data and to help us to make our database easily searchable, and also to look for intercoastal and intracoastal mathematical correlations within our data set. So these are not people from oceanographic background, they're pure mathematicians and engineers, so they're just looking at this from a purely mathematical and statistical point of view. But that's just one example of kind of a partnership that we have ongoing, and the one with the European Space Agency with Copernicus, where that's a direct use of our data to improve sea satellite temperature measurements and to extrapolate from them. That's all that comes to mind at the moment. I hope that answers your question, but if it doesn't, please don't hesitate to specify it.
I think at least it gives an overview where you are and where we are with this device, let's put it that way. I understand that there are quite some few users already on the user side, on the user end, who of course give input. They provide the wish list, so to speak, where to develop further. And then the other side is the hard end, so to speak, where you have to find out how to make it work.
Yeah.
So that is, I think you covered both sides, and that is nice. Perhaps at some point we find some people here in Finland as well. I think that is what Emma is pointing at. She might have some knowledge or might have some friends. You never know whom you meet tomorrow. And at the dive site, at the water, at the water, and talk about something, and all of a sudden something pops up. So yeah. I think that can be developed further, because I see there's a lot of potential for further development to different aspects. You said it already, like conductivity, like maybe no current you cannot measure because you're dynamic anyway.
Yeah.
But the salinity, of course, is an issue also here in the Baltic, very specifically in the Baltic, I would say, because we have big gradients across the Baltic itself, from the Ostrobotnian Bay, where there's almost fresh water, and then you go to the direction to Denmark. There between the islands, you have almost seawater. So it is the whole gradient we have here, and I think this would be very, very interesting to get more data on that. Of course, it is measured professionally, etc., etc. That's where we know it from. But of course, the changes that now come with the global change, that there is more rainfalls and things like that, how that impacts in a certain area. At least on the short term, that can only be measured by hundreds of devices, which we can bring in as divers. The professionals Absolutely. Don't have that workforce.
Absolutely.
So I think this is a brilliant example, I think, where we can contribute significantly to better understanding what's happening, the dynamics of our water body in front of the nose, which we use as our playground, let's call it like this.
Yeah, we have an opportunity as divers. The community of divers can achieve something that there's no other way of achieving, really. you know, through citizen science. So yeah, it's really exciting, and I'm really grateful for this opportunity to speak with you guys, and hopefully to, you know, develop this project in Finland and the Baltic Sea and the polar region. So that would be fantastic. Yeah, that would be great.
Yeah, as you said that, do you have an anticipation when the next model would be available? Is there
I'm receiving a prototype Monday, and so I'm gonna be testing it here all of next week. And if that goes well, I don't want to make any promises, but hopefully we could go into production before the end of the year.
Okay, that's at least opening some hope.
Yeah, I was hoping August.
Good.
I was hoping August this year, but here we are.
But everything takes longer than we think
Yeah.
or hope for. That's quite normal, I think, especially with those things where you never know what surprise comes tomorrow. As small things, devil sits in the detail. I don't see any more questions at the moment, and I think you have exhausted everything you wanted to say. Or is there something still? Then please come up. Because otherwise we would have a. Yeah, I would thank you very much and for your contribution, and looking forward to continue on this road.
Thank you all very much.
Certainly something which we are, you see it, you hear it, which we're looking forward to. So, yeah, thanks a lot, and hopefully very soon we be in contact again.
Thank you very much. Have a great end of conference, and thanks for having me.